Hi everyone, can everyone see my screen and hear me properly? Hello. I'm sorry, Rohan, I don't know if I'm
Okay, no worries.
audible.
Yeah, this is good.
Okay. Okay, sounds good. Um, so hi everyone. I'm Richa Gupta. I'm dual master student here at MIT in design computation and computer science. Prior to this, I have been in design and technology industry for 4 years, where I was incorporating emerging technologies in design workflows. Today, I'm going to discuss a bit about emergent behaviors in generative artificial intelligence in design. Thank you, Rohan and the team, for inviting me at Brain Bites and Big Questions. So let's dive directly into construction industry. Now, this industry has several biases, among which these are the two more prevalent, gender and race. Men continue to dominate this industry, but also discrimination leads to the prevention in acquiring skills, which lead to incompetent journey. Be it social constraint or policy issue, these biases reflect in data, and further, this data is helping to train AI models. Let's see how. So AI models are the reflection of society. The training and processing of AI models can embed biases into their output. This affects fairness, inclusivity, and accuracy of the results, making transparency in how models are trained crucial for responsible use. So this is where author gave engineers as a prompt. So above two are the rows where they are just doing image search. And we can see the biases exist where we are able to see only men. And now in the second other two rows, we see that how these AI generated from DALI and Stable Diffusion, we are also facing the same biases. Now, these biases affect the future as well if the decisions are based on AI. In this example, author gives office as a office in Ethiopia. So if you see the first two rows, right now the Ethiopia has more modern buildings as well, but DALI and Stable Diffusion predicted very poor economic condition when we write Ethiopia. So this visual representation is the framework for understanding the social biases in text-to-image generation models. It underscores the critical need how these elements are intersecting to ensure fair or unbiased output and from these AI-generated systems. So it highlights four main components, which is social bias, dimension, social bias subjects, model and data, and evaluation of these methods. Now, addressing these biases require robust evaluation and diverse data sources and awareness of the dimension that subjects have affected. These findings here are, I'm not sure if you're able to see, but these findings highlights the need for ongoing evaluation and improvements in AI models to avoid reinforcing societal stereotypes and to promote fairer representation across gender, race, age, and other factors. Now imagine with these biases that we are existing with, and they are going into AI model, we are trying to design cities, buildings, and above all our habitat, the whole built environment. A doctor treats one person at a time, but a building treats thousands at a time. So Friedman in his paper says that, however, it is easy not to design the whole original building, but which requires architects to balance material constraint, environmental factor, and often it leads to innovations and styles. So here's a study how different models have different approach or output. It is evident that the rendering styles are influencing aesthetics. What I mean with this is that these, like beyond aesthetic, the depiction of materials are also questionable. Once we try, like on the one hand, we're trying label environments, and the other we are looking at superior texture or like highly textured uh, outputs. So let's talk about how design affects overall impact in the built environment. So if we see this graph, it is quite easily understandable that how early phase decision impact in higher in conceptual stage, which later results into environmental impact. And if we see here, Sherwin and Varma is mentioning that true innovation lies in the design process. That means we need to work on the design process. The current scenario in the construction industry, if we have to like see on the broader scale, we have pre-design where we do research, we have design and documentation, then we go for pricing, and then we go for construction. Where LCA comes, which is the life cycle assessment, it comes literally like quite late in the process, where it is design development, where the design has already gone through one route of like acceptance. And at best, it is prior, little bit between schematic design and design development. So what if the decision we make at very early stage, the conceptual stage that we were talking about in earlier slides, can also have some information that are related to LCA or other information that are relevant. This will definitely help us make better decision, A, and this will result into better built environment. So at this stage where we're talking about pre-design, the existing use of AI is through stable diffusion, which is like text to image model, and designer gives rough model to generate a visualization. As we can see, using those models, we are able to tailor the visualization. They are pretty pictures. So each visualization is based on what the text prompt you have given. Now, interestingly, what if we can have such system that can accompany with also the information that are relevant for the user to make informed decision? That is my argument. So hence, what I'm trying to say is, what if we have some extra insight? Now, these, if we are putting extra insights, A, they should not be artificially intelligence generated, because we need to avoid the biasness. We need some real world data. And number two, we also need some contextual data. What I mean by contextual data here is something, if I am an architect, I see architectural relevant insights. If I'm a landscape architect who works with greenery, they should be able to see their sort of insights. Now, here is what I'm thinking, where what I'm trying to say is that we have existing design workflow, as we can see here, and then we have post-processing, which is like with the real world data, and then we get an output, which is not only this image and text, but also the insights that are relevant to the user, which I call here design specific, we can call it domain specific, and whatsoever. So as an architectural design use case, I am giving you a short example, is like if you have generative AI output, which is the old version, we want to reach to the domain specific generative AI. What it does is, the existing workflow is that you make a 3D model, which already saw, we give text to image and we get visualization. We will follow the same path, but can we do the post-processing like segmentation, computer vision techniques, database query of the real world, and extract materials that are suggested by generative AI? Then we can also look into the sustainability feature. This will help us to understand the feasibility of the material used. What I mean here is, for example, if a material can be used, but is it even readily available? If it is available, what is its sustainability content look like? What is the cost of material? Because a lot of times such design decisions can take prolonged process, like you have to go back to design process, or we have to sacrifice on something or the other. So if we have these information ready, it would be much more easier to make better decisions. And obviously, if we can have some vendors and their supply, this is one use case how we can think of. To summarize this whole idea of emergent behaviors in generative artificial intelligence, we talked about the real world bias that translate into artificial intelligence. Now that bias, artificial intelligence, lead to design bias. And the example of design bias, we also saw that. Further on, what we saw is the importance and impact of design phase. And it is not only true to construction industry, but any industry, be it product or etc. Then we saw like how early design phase has some disruptions, and can we give some properties to the insights that we were talking about, and these properties should not be artificial intelligently generated. Rather, they should be real world incorporated data, but also contextually assigned. And then we also saw like how architecture design workflow in total can be incorporated in such scenarios. I think beyond this, also, it is not only adjusted to design field, but maybe healthcare. For example, if someone is in the radiology, they can see the imaging plus also the data that can help them to analyze the whole imaging nicely. The overall idea here is to accompany the real world contextual data to ensure AI biases doesn't affect efficiency. Thank you. AI models are indeed the reflection of our society. I would like to know your point of views.
Thanks for that, Richa. We'll take 3 questions from the audience. Yeah, whoever has a question, just raise your hand. Yeah.
She'll hear me, what's that?
Yeah, she can. Yeah.
Hi, thank you for the presentation. I was curious, if we take an element like wood, for example, right? Suddenly the way you build a structure changes. So it's not just aesthetical, you have to account for wood is perceived differently by in different places. It might be difficult to find local expertise. Although the life cycle of wood is interesting, if you have to work across the ocean, if nobody has local expertise to work on that, it changes the way you build, literally the building, it has new constraints. When you work on those models, the material selection, for example, is done after modeling. Is that, what's the constraint behind that?
Okay, so actually it's quite inaudible, but what I understood from the question is that when we are giving references like references like geographic references, or we are giving materials and vendors, you're asking like what is the constraint when the model is ready and then you are applying the artificial intelligence? Is that a question?
I'll try a bit louder just for the overall, yes. But in the graph you presented that traditional models are used to make the modeling, but then you use new methods that tries to account for biases when you do material selection. But then you might have a design for the building, but then if I propose a type of material that's not compatible with that initial 3D structure, I have other problems, for example.
Yeah, so let me just go back to that slide. So here what happens is, yep. So here what happens is the 3D model is made by the architect or the designer, whoever is working on the project. Now, when they give this text as an input, what happens is they will specify something because they're not talking in layman terms, they're talking in very specific terms to generate these images. Now, once they generate these images, what happens is, for example, in this case, if they generate this image, maybe let's say this image, and they get like, okay, these are the materials available. Now, what it does is, alongside the image, if I'm seeing the insights, imagine if I can go back in the model, okay, if the cost is more, I can increase the window size to reduce the panel, right? I can also see, okay, if wood is giving me a problem, should I apply some other sort of panels? So I will try to specify in my prompt again. So it's an iterative process which will be supported. So the biases would be reduced. So in total, what I understand is like any model exists, they are hallucinating. It's what extent of hallucination that you can intake. In this case, if I am having real world material, not just a fancy picture that we are having, that picture or material itself can have multiple options. Okay, so nearest to this would be this, nearest to the environmental aspect of it would be these. And then a user can give filtering like, okay, these are the necessities and or can select out of them. Once they select, it applies back to the model. That's the idea. Like you are not stopping with the image, but also you're applying back to the 3D model.
That's it. Thanks.
Any other
My
questions?
pleasure.
I was just curious, in practice, do designers, are designers already using these AI generated diffusion results to aid their design? Like, how close do you see these diffusion results being accessible to designers to kind of give them feedback on their work in real time?
Interestingly, I cannot account for like a lot of people using it, but definitely significant amount of people are using it. If we look at the firm types which are like above 100 people, definitely they're using it because they have or they try to use such advanced tools to make sure like they are on top of their their peers. So they are using it. Now, at what extent it is useful in the industry is questionable. So some people use control nets, which is trained on their own data sets, the kind of design styles that they like. Some people just use it for quick rendering so that they can go to the client and show it to them. So once they go to the client, for example, in this case, if they go to the client, what happens is when they come back, they realize, oh, the cost that we incurred, we thought is not matching, or the sustainability aim is also not matching. So such interaction of mismatch could be helped through this sort of maybe arrangement. But how many people are using is questionable. But definitely what I feel, if such systems can assist, definitely there will be higher adoption of such tools in design industry.
Thanks so much.
Any others? Okay. Richa, thank you so much.
My pleasure, guys.
Yeah, all the best.
Thank you so much. Thank you so much for having me. You can just write to me if any case you want to connect or talk about it.